This lesson talks about reflections on the coordinate plane. So when you think about reflections and how you've used them in the past, I believe you've done reflections across different lines in the past. A reflection creates a mirror image of itself, and we are used to reflecting over x-axis, y-axis, and I'm going to show you a couple more, the line y equals x and the line x equals 1, just for a different example, because the process is the same no matter which line you're reflecting over. So if you take the point 4, 2 and you reflect him over the x-axis, that means he's going to be down here, as best as I can draw that little dot on this grid here. My new point is going to be for -2. So when I reflect over the x-axis, I'm basically I'm negating the y value, because he's still, the x value hasn't changed. He's still over here at 4, and the y became negative. So if we reflect over the y-axis, this dot is now going to pop up over here. So he's going to look like 1, 2, 3, 4. It's hard for me to see this. 1, 2, 3, 4, up 2. So he's over here. And that coordinate is now going to be -4, 2. So when we reflect over the y-axis, this creates a mirror image on the other side. You could fold this image on the y-axis and the 2 points would meet. So my y value did not change. He's still at 2, but my x value negated. So we can do a similar process for the line y equals x. Now the line y equals x is a 45-degree angle. It has a slope of 1. It cuts through the origin, so it's a diagonal line. And when I reflect him, he's going to be a mirror image over this line. So if I were to fold this image, he's going to end up here. And you're going to kind of move perpendicular to the line to get to the other side. So he's going to end up, if I visualize it, right up here. And if you think about where that point is, he is at 2, 4. So I started off with 4, 2, and my new point is 2, 4. So there's a pattern to that as well. Finally, we can reflect over any line. And again, what we are doing is creating a mirror image of the original point. So if I have my point out here, he's still at 4, 2, and I reflect over the line x equals 1, that means I'm going to be the same distance away on the other side. So if I'm 1, 2, 3 points away to the right, I'm now going to be 1, 2, 3 points away on the left, and that is, looks like it's -2, 2. So I'll put a point there. -2, 2. There we go. So for the first 3 reflections over x, over y, over the line y equals x, we have a rule that we can follow. For the last one, we have to really do it visually because the rule gets a little complicated. So remember, the last one, you just want to put this point in the same relative location on the other side. The rules for the first 3, if I'm reflecting over the x-axis, I'm negating the y. So reflecting over the x-axis, xy, is going to map to x -y. If I'm reflecting over the y-axis, I'm negating the x. So xy turns into -x, y. And then if I'm reflecting over the line y equals x, xy turns into yx. These are 3 rules that would be very helpful if you memorized, if you haven't done it already. I know you've done these rules in the past. Again, if I'm reflecting over the x-axis, I'm negating the y. Y-axis, I'm negating the x. The line y equals x, and remember that was the line that was at the angle with a slope of 1. I switch x and y. Okay, so we have some vocabulary to understand. A few definitions. A transformation is a change in the position, shape, or size of a figure. And we know those transformations. We're going to talk about a lot of them, and reflections are just the first one. A reflection is a rigid motion, and that's a transformation that changes only the position of the figure. It doesn't change the size. The length and the angle measures are preserved. And then an image is a result of a transformation of a figure. So that's what you create once you reflect the image. And the original is called the pre-image. So to identify the image, we're going to put primes on our letters. For example, the point A is now going to be A prime once I change it to, once I reflect it over a line. So here's our first example. Given, and we should see a triangle symbol there. Let me put that in because that's going to drive me crazy. All right. Given triangle ABC with these vertices, we're first going to graph the triangle on the coordinate axis down here. We have our x-axis and our y-axis. So the point -5, 1, I count to the left 5, 1, 2, 3, 4, 5. I count up 1, and there's point A. I graph it and I label it. B is -1, 1. So B is right there. There's B. And C is -1, 7. 1, 2, 3, 4, 5, 6, 7. There's C. There's my first triangle. So what I'm going to do next is I'm going to graph the triangle A prime, B prime, C prime, which is the image of the original, reflected over the x-axis. So when I reflect over the x-axis, my first image is going to be down here, and my primed image is going to be a mirror reflection. So when I do that, I'm reflecting over the x-axis, which means I'm negating y. So here's A prime. He's now at -5, -1. B prime is going to be at -1, -1. B prime. And C prime is -1, -7. 1, 2, 3, 4, 5, 6, 7. So there's my first image that I created from the pre-image ABC. Now, it's always a good idea to write your coordinates down. Usually it says graph and state the coordinates. So A prime, just using the rule, is now at -5, -1. B prime is at -1, -1. And C prime is at -1, -7. Part C says on the same set of axes, graph A double prime, B double prime, C double prime, the image of the original graphed over, reflected over the y-axis. So here, if I start by using the rule, I'm basically going to, if I'm reflecting over the y, I'm negating x. So my double prime A is going to be at 5, 1. My double prime B is going to be at 1, 1. And my double prime C is going to be at 1, 7. So 5, 5, 1, 1, 2, 3, 4, 5. Here's A double prime. B is at 1, 1. That's B double prime. And C is at 7, 1. You have to label with the primes. And when you're done, you'll see that everything, if you were to fold over the other axes, the image and the pre-image should match up exactly. All right, in our last example, in our final example, we are going to reflect triangle ABC over the line y equals x. So as a reminder, this line is a diagonal line, has a slope of 1, up 1 to the right 1, up 1 to the right 1, cuts through the origin. So first thing I'm going to do is use my rule to write down the new coordinates. If A is 2, 3, then my reflected line A prime, I switch x and y. He's going to be 3, 2. B prime is going to be 6, 0, and C prime is going to be 6, 2. If you know the rules, then this is a lot easier sometimes than visualizing the reflection over this line. So now I just graph the points. 3, 2. There's A prime. B prime is 6, 3, 4, 5, 6, 6, 0. So B prime is down here. And then C prime is 6, 2. If you do it correctly, it will create a mirror image of the original. Now finally, we're going to graph over a different line. We're going to graph the image of the blue, A prime, B prime, C prime, reflected over the line y equals 2. Actually, it should be y equals -2, but my negative, I don't know why it didn't show up, but it shows up on your paper. So y equals -2 is going to be this line. and I'm going to reflect the blue image over that line. So this one you really should do visually as opposed to trying to use a rule. So if I do that, I just count over 1, 2, 3, 4, 5, and I'm going to count over the other side. 1, 2, 3, 4, 5. There's A double prime. As soon as I can get there. 1, 2, 3, 4, 5. So it's going to be the same distance away on the opposite side of that line. B double prime, if I count over, I'm at 8. So I got to count over again, 8, which puts B double prime way over here. And then C double prime ends up being right there. So again, this is a mirror image over the line y equals -2. If you fold over this line, the primes and the double primes should line up. I'm going to write those coordinates down though. A double prime ends up being -7, 2. B double prime ends up being -10, 0. And C double prime is -10, 2. So those are different ways that we're going to be reflecting images over various lines in class.